In this example, we want to look at the difference between a more straightforward probability versus a conditional probability. So we have these shapes. It says, suppose the numbered shapes are placed in a box and one is selected at random. So these 6 shapes are in a box. It says, find the probability of selecting a shape with an odd number on it. So this is a more straightforward probability where you're just looking at how many shapes have an odd number on them. 3 out of the total, 3 out of 6. So that probability is 1/2. Then we have a couple examples with conditional probability. Part B says find the probability of selecting a shape with an odd number on it, given that a star was selected. So it's the probability of getting an odd number, given, this vertical bar means given that a star was selected. So there's a couple ways you could do this. You could use the formula probability of A given B is the number A intersect B over the number of elements in A. So in this case, your A is your odd, your B is your star. So for your numerator, you're looking at how many of your shapes have an odd number and are a star. And it's just this one. Then your denominator is just your number of stars. It's the second. It's the number of what's given, the number of stars. So there's 3 stars total. So that probability is 1/3. Looking at it without the formula, the idea is if you're given that a star was selected, that means you know it's none of the other shapes. So notice, out of the stars that are there, only 1 has an odd number on it. So 1 out of 3 that way. So you don't necessarily have to think about it as being a formula if you understand what's being asked. In part C, it says find the probability of selecting a triangle given that the shape selected has an even number on it. So if you're doing the formula, your numerator, you're looking for the intersection of the two. So you're looking for any triangles that have even numbers on them. Looks like it's just this one here. So just one of those. And your denominator is how many of what's given, how many even numbers you have total. Still looking at all the shapes. If you look at all of the shapes, we have 2, 4, and 6, 3. So that one also comes out as a probability of 1/3. Once again, if you don't want to think about it in terms of your formula, you were given that the shape selected had an even number on it, so automatically you could disregard these other ones because you were told that you drew an even number. So then you're looking at the probability out of those that are remaining. Notice that there's just 1 triangle out of the 3. So it's just 2 different perspectives. You're calculating the same probability just from 2 a little bit different points of view.